Good morning, students. So today I am going to explain the next topic of the Newton's first law, Newton's law. Today I am going to explain the Newton's second law. In the first law, we have discussed that if the body is at rest, it remain at rest. If the body is at motion, it remain at motion unless the force is applied on it. So the second law says that if two bodies of different mass, first mass are different, one is suppose having a 20 kg, another is having a 50 kg, so they are in same velocity, means with same speed and time, they brought to rest. If we want to make them in rest, so force needed to stop the heavier body is more, we need to apply the more force on the heavy body than the light body. Similarly, firstly the different masses. Now the same if the mass is same but the velocity is different, that means speed and time is different, so there also force needed for the faster body to make them stop is more. So that means linear momentum, two things are there, mass and velocity. So linear momentum is the term which can relate about the mass and velocity. So what is the force needed to stop a moving body in a definite time depend upon the mass and its velocity. So the term which can relate tell us about the mass and velocity, that is a product, that is a linear momentum. So linear momentum of a body is the product of mass and velocity. Definition is very important. So we can denote with the term P. So the relation between the mass and velocity with the linear momentum is P is equal to m into v, because it is a product. So linear momentum is a vector quantity because it tells us the speed as well as the direction. So SI unit of momentum is very important because this topic same you will get in the 10th class also. So SI unit of momentum is kilogram mass per second and CGS unit is gram centimeter per second. So how can change this sign? This sign is a delta sign. This sign, where this sign comes, that make it sure that there is a change in momentum. If the change in momentum, that means there can be a change in mass and velocity, there can be change. Okay, so this sign is symbolized as delta or del, we can say, and it is denoted as change. Okay, so if the delta change in momentum, there can be a change in mass and velocity. Mass can, is it possible that mass is constant and velocity can be changed? If velocity can be changed, delta momentum can be changed. So this paragraph is, students, are very important. So how can, is it possible that if the speed of light is less than the other mass but the increase with the increase in velocity? No. So this delta momentum is mass change in velocity is true only, otherwise we cannot write delta mv is equal to delta m into delta v. We cannot write like that. This can be true only. This is very important because the examiner can ask from this paragraph only. This can be true only if the velocity of v of moving particle is much smaller, means if the speed, this, what is v? V is the speed of light. Okay, this c is the speed of light. Okay, velocity of light, that is 3 into 10 raised to power 8. So if the v is very less than the speed of light, then only we can say that delta momentum is change with the mass is constant and velocity is change. It happens when the velocity of particle of the is the order of 10 raised to power 6 meter per second. So however, the relation delta p is equal to delta change in mass and velocity is always true. Okay, this is very important paragraph. So rate of change of momentum is, how can you drive the rate of change of momentum is very important. So initial velocity we are having a initial means u, final means v. So mass into initial velocity into mass into final velocity. Change in momentum means final minus initial. So take the m constant from here. Okay, so change in momentum is equal to, we are having a change momentum is change upon time, that is mass into v minus u upon t. So acceleration, we are having a formula v minus u upon t. So change in put this a over here instead of this